All right. So when you look at this, I'm going to make this big. Come on. All right. So what we're doing here, right? We're going to do a couple different things. The first thing, well, actually, we'll do that second. So the first thing I'm going to do is I'm going to show you what a profile is and how to do a profile. Remember, a profile, right, is like a side view of your face, right? If you look at your face, a profile of your face would be how your face is shaped. This is the same exact thing, except we're doing it with land, right? So we're actually going to get a look at what the hill would look like if you're looking at the hill, how it would be shaped. Similar to what we would see if we had didn't have fog out there. You would see the shape, the outline of that hillside, right? The profile. So we're going to look at that. We're going to be able to do that because you can actually graph the profile. So the way you do this is this. And that's why I did 2 at a time, because you're going to set, instead of giving you guys each a white piece of paper, you could just use the back of one to do the other. So I'm going to start with figure 2 first, and we're going to do BC. So the first thing I need to do on this diagram, let me get this out of my way. Move this out. So first thing I need to do is I take my white piece of paper, right, and I put it across my dotted line. We are going to do profile BC, as you can see down below, right? These pre-done ones, they're a little bit off just because of photocopying, but they should be pretty close. So I'm going to take my paper and I'm going to put it along my dotted line, and I'm going to mark where B and C are. So I know where they are. It's the back side of the figure 4. Right? So I'm going to go ahead. Yep, I have the figure 4 is upside down. Like I took my figure 4 paper and I just turned it over so I had a white side. So you have your paper like this, right? What I'm going to do now, right? And I don't want to necessarily pick it up right away because I've got to figure out where this stuff is. But what I'm going to do is everywhere that a line, right? See how this one's 550, right? Everywhere where a line crosses, I'm going to continue it onto my paper as a straight line. Now, the reason why I do it straight is because in case you have really close ones, if you do it at an angle, it will actually interfere with the other ones. So everywhere it crosses, I'm going to put a line, because you'll see in a minute. So now I have on my paper, I have lines where those cross. All right. So every line that crosses, I have a line. Now I'm going to put, now I have numbers associated with these. So I'm going to put the numbers with them. So this one here, right, B is 550. Now you can do it. In this one, you can probably do it out sideways, but a lot of times what I'll do is I'll do 550 like this, down, so that it doesn't, because what'll happen over here is you'll have one side, you know, you have to make longer lines, or you can do a bunch of different things. They show longer lines, like when you do this, like if you look in the book. The next thing I need to do is I need to figure out what the contour interval of this map is, okay? So if I'm going to look, it might be on here, and it is. It says 10 meters. So my contour interval is 10 meters. So that means every line is 10 meters higher or lower than the last line. So this one is 10 meters. Now, if I'm looking, it doesn't make a difference which way I'm going, but if you notice, I'm going down to a stream, or I'm going to a stream. You can't see it all that well, but it's right here, the white one, right? The Woodland Brook, right? That line there, right? And I draw a line there because I actually want to know where that brook crosses my line. So I just follow it along. If you can see the white good enough, then just leave it. If you can't, then do this. So I know this is where my creek is. Anybody know why I would do that? All right, I'll show you as we go along. So this next line here, right? In this case, I'm going downhill, right? Because I'm going towards a creek, I'm going downhill. So in this case, this one is going to be 540 because I'm 10 meters less, right, than the 550. Now, I also can tell that this is going towards a hill because it has lines inside of lines, which means that it's increasing towards the top of a hill. So I know this is increasing. I also see half of them, but I know that this is circles inside circles, so this is a hill as well. Not to mention the fact that I can see this valley. Which way is the stream moving? It is moving northwest, right? Here's my where they cross, right? They point the opposite direction, so it would be moving this way. Right? Yeah, don't draw the Pac-Man. You can draw the Pac-Man, just don't write answer that it's Pac-Man. The Pac-Man's eating downstream. That doesn't work out very well. So if you look at this line, right? This line goes off the map. So this is going to be a new line, right? And you have to make the assumption that we're still going downhill because we haven't moved up, right? So this is a new line. So we're going downhill, and this is going, and you could actually do it this way if you wanted. You could go the other way and figure it out. So, you know, this would be 510, 520, 530, right? And if you go 540, 530, so this is going to be 530, right? Then I'm going to mark my stream. And the way I mark my stream is, in this case, I know I'm going, I know already that I'm going hill to hill. So I'm going to actually put an I'm actually going to put a V here, right? Where the point is right even with where that stream would cross. And the reason why I do that is because I know that I'm going down to the creek, right? But then I'm going back up. So that shows me, my V shows me that I'm going down and then coming back up. If I was going to a peak of a mountain, I would actually draw a caret going the other way because I know I'm going up to the peak and then back down again. Yeah, it's called a caret. When it's over top of a thing, it's called a caret. No, if you want, you can call it an upside down V if you're more comfortable with that. But there's no number associated with this. There's no number associated with this because it's not an elevation, okay? So now I'm going back up, right? If you look, right, look at my 530. Goes around, crosses the creek up here, comes back over, right? So this number and this number are going to be exactly the same, right? So this first line, I'm going to draw a little bit longer. Right, this is going to be 530. Then I've got 540 because I'm going up one. And then I have 550. Right, because that's the dark one, 550. Right, I'm moving up. Now, if you look, right, this line, dark line goes all the way around to C, which is also 550. Because it's the same line. Remember, iso lines, including contour lines, which because they are iso lines, have equal points of elevation all the way around it. So it's going to be the same. All right. So now I have my lines where my lines are, and I have my elevation changes. That better? All right. So now I have this. All right. So now I've got to transfer this information to my graph. You have to think of this as like your X, these lines are your X axis. All right. They're going to be your delineations of separation. So I'm going to take this and I'm going to match up my B and C. Right, my B and C. And it should line up pretty close. Copies are a little rough sometimes, but whatever. But if you notice, my first line is at 550. Now you can do this a couple different ways. You can leave it right here and move your hand up and mark the spot like I would mark here. I prefer to slide my paper. So I will bring my paper up to 550 and I mark it. Right, so I'm going to mark my spot there. Yes, sir. Okay. Right, so 550, so I marked it. Right, now I'm going 540, so I'm going down. So I'm going to slide it down to the next line, but I have to keep my B, right, and C lined up. More importantly, my B. So I want to keep this line that I drew, even with this line here. It would be considered your y-axis on a graph. And then I'm going to mark my 540. Right, I'm going down again. So I'm going to 530. Right? So I'm going to put a dot here. Right? Now, here's my V. I'm going down and coming back up. And so I'm coming back to 530. So I'm staying right there. I'm not moving anywhere. I'm going to mark that spot. Now, if you notice, I'm going up. So I'm going to slide my paper back up. making sure that B stays even, and I'm going to mark 540. Right? Then the next one, I go all the way back up to 550, and I mark my 550, and now C stays the same at 550. Right? So I have all my dots plotted. This is where the tricky part comes in. So we have a starting point and an ending point, and we have a spot in between. This spot right here is where our river is. All right. We don't have an elevation for our river, but you should automatically know that if you were to measure where the top of the creek is, right? What's the under part of the creek like? It's lower, right? It's lower. So that means that somewhere in that creek, it's got to go lower. However, we don't have a line in there, so it can't be the next contour down. So in other words, it's 530, but it can't be, it's going to be under 530, but it cannot be 520, because if it was 520, there'd be another contour line there, and there isn't. So in this case, right, when you do these, and I do my hills and valleys first, that's just the way I do it, so I know what I'm doing. My valley is right here. I cannot touch the 520 line. If I do, I am wrong, right? No. As long as you go below the line, right, and don't touch the other one and then come back up again, you are fine. If you touch this line or that line in between these two dots, you are wrong. So you just put this little smiley face in there. Now, when we get up to the top of the mountain, or up to towards the top of the hill, between this dot and this dot, right? The hill is still, we're still in up mode. We're still going up, right? Our elevation is still going up at that point. So in this one, right, we have to go up because there's no depression lines, right? So we're assuming that the elevation is going to go up. However, where our line crosses, notice up further, right, there are circles, right? But where our line crosses, there is no elevation change going up. However, right, it's not the same as 550. So in this case, right, our loop is going to go up, right? But it can't touch 560 because there's no line there, right? But it's got to go up. So it comes up and then comes back down. So anytime you come to the top of a hill that doesn't have an exact location, which would be a benchmark at the top, you must loop over. Right? And then once you're done with that, once that's completed, then you can connect the rest of the lines with a loose line. And that's what your gradient, that's what your profile looks like. So if you were to stand down here, right? If you were to stand down here, right, and look this way up the hill or up the stream, right, you would see what you see from B to C. Right? It would look like that. So if you were to stand right here at the lake and look at that hill, right, it would literally look like that from B to C. It would go down a little bit, like very gradual. And then on the other side, it would go up a lot steeper up to the top of the hill. That's the way it would look. So this is showing what it would look like if you were standing in the stream, or, you know, standing in the stream looking up from the lake. That's what this shows. All right. So now, what I want to do is I want to take point A, right? And I want to find out the gradient. Actually, let's do it. I'll make it easier. We're going to do the gradient. I'm going to put a spot here on Woodland Creek, right? So this is going to be spot D. Hello, Mr. Murphy. Okay, thank you. Bye. Matthew Tate. Bye. After I'm done with this. So here we're going to find the profile. We're going to find the actual gradient from D to C. So gradient, right? If you look at the front of your reference tables, gradient equals change in field value, and I'm going to use my triangle, right? Change in field value, right? Over distance, right? Change in field value over distance. So now I need to figure out what my distance is between D and C, and I need to find out what my change in elevation is. All right. So the first thing I have to do is I can find my distance from one to the other. And all I have to do is put my white piece of paper again here, and I mark D and I mark C, and I put it here. And it looks like it's 0.4, right? So it's 0.4 of a mile. Where's my thing? So G equals, right? And this is going to be 0.4, and that's kilometers, sorry, kilometers. And then my yeah, because this is kilometers, right? Kilometers. And my elevation change, right, from this, right, is going to be what? So we have, this is about 530, right? Because that's our last contour line, right? It's 530, right? So 530, I'm going to put it over here because I know I'm going to subtract the higher number. And then C is going to be 550. Right. So G equals 20 divided by 0.4. And this is in meters. Why are you waiting for me? True, but that doesn't matter.
It's 50, Michael.
I gotta go to the bathroom, Mr. Murphy, hurry this up.
Holy cow, that's going really slow.
So in this case, right, it's going to be 50 meters per kilometers.
Did I get 50? No. Yeah, I got 50.
Right, 50 meters per kilometer. That's going to be my changing up my slope. Now we know it could do this, but our average slope, right, is going up. Go. All right, so now I'm going to leave AB up for you. So do the profile, and then we'll do the gradient. We'll do gradient. Oops, gradient of CD. So I want the gradient for that, right? CD. And this AB, you have to do the profile. So profile here, profile here, and gradient here. Your profile is from A to B. It's down here. The gradient is from C to D. It doesn't matter.